Lesson 9.4, solving polynomial equations in factored form. So, how do we solve 3x minus 4? Well, most people remember. We add 4 to both sides, and we divide by 3. X equals 14 over 3. And we can plug it back in and see that it works. When we do that, give it a little check mark. So how do we solve x minus 4 times x plus 2 equals 0? Because there are two x's now. How many solutions are there going to be? Well, now we're actually going to have two solutions. Which is definitely different from before when we only had one solution. How do we get that solution? We need something called the zero product property, which is right here. That says if we have two things, that's number 1, whatever A is, that's number 2, whatever B is, and they multiply together to equal 0, then one of them has to be 0. And it's or, they don't both have to be 0, just one or the other. So if we had x times y equals 0, we could have this be, I don't know, anything, 72. As long as this is 0, we'd get 0. Or vice versa. This could be anything, negative 7/3. And if this was 0, multiply out, there's 0. So, here's how we solve. Break the problem in half. Like we just said, either one could be equal to 0, so we do it twice. We say x minus 4 could equal 0. Solve it. And as you get better at these, you won't have to go through this whole process. You'll know what the answer is before you get there. Or we could say x plus 2 equals 0 and solve it. So our answers are either negative 2 or 4. Either one works. So, try it. X plus 3 equals 0. And now I start shortcutting right away. I know I'm going to subtract 3 from both sides. X plus 1 equals 0. Either one works. You might want to pause the tape now and see if you can do the rest yourself. They're really not that hard. And we really didn't have to do this twice. It's the same answer, so we could have just done it once. And finally we get to this point here. X equals 1/2. X equals negative 2. How am I doing that so quickly? I just look at this. If it's positive 2, it's going to be negative 2. If it's negative 1/2, it's going to be positive 1/2. A little bit trickier here. We still got to solve it. Some people can do this in their head. X equals 2. So notice, this has all the steps. This does not. And I did this one faster. Please look for the patterns. It can make your life a lot easier. You just look at a problem and say, oh, that's going to be negative 1/3. Oh, that's going to be 4 over 2 is 2. Definitely want to save time if you can, because this is going to be the last step of a multi-step problem. We call these solutions roots. Why? It's a long story. That's just what we call it for now. Do each of these equations have two roots? No. The one up top here did not. Had two roots that were the same, so we'll call it only one. Usually two roots, but not always. So, back to our original question. How do we solve a nonlinear equation? Nonlinear meaning x squared. That makes it nonlinear. If I graph this, it'll be a curve. Well, first you factor out the GCF, because we're going to try and use that zero product property we just showed you. What is in both of these? Well, 2's in both of them. This is x squared and that's x, so I can pull out an x. Now I'm not just dividing them. You can never divide by 0. Pardon me, divide by a variable. Because a variable might be 0. 0. So we're factoring it out. We pulled out 2x. What's left is x plus 4. At this point, you're probably saying, what just happened? I don't know. Go backwards then, or go forwards. 2x times x is 2x squared. 2x times 4 is 8x. So all we're doing is breaking it apart. And now we have it where we can set it up. 2x equals 0, x equals 0, x plus 4 equals 0, x equals negative 4. So that's it. The key thing to remember, though, is always set equal to 0. If you don't do that, going to have problems. A lot of people look at this problem here, and they do not do it right because they start solving it without setting it equal to 0. You can see where all of our work, the adding and subtracting polynomials, comes into play. So there's step 1, set equal to 0. Step 2, factor out a GCF. Well, there's a 3 in both of these. And then there's an x. So I pull out 3x, I'm left with 2x minus 5. Break it into 2. X equals 0. And check. If I put 0 in here, I get 0, no problem. If I put 5 halves in here, that's 25 over 4, which is 75 over 2. And put it over here, I get 75 over 2. So they both work. Do you have to check? Yes. If you forget to and you get it wrong, don't cry to me. One more example, then I'll let you try them on your own. There's no numbers in both these, but there is an A in both. Check them both in. 25 plus negative 25 equals 0. 0 equals 0. They work. Try the next two on your own. And see if you got them right. Notice this one, the 1 here, often causes lots of problems. When you divide by 2x, all you're left with is 1, and then don't forget the negative out front. Again, just need to practice. That's it. Good luck.